Hello, good morning. Welcome to my channel. Today we are going to talk about what is Kubernetes and when should we use it. So before we start Kubernetes, let's take a look to Docker. Okay, let's take a look to Docker. What is Docker and how we basically create a Docker container? So generally what happens is you write a file that is called as Docker file. You build this Docker file. When you build a Docker file, you will get a Docker image, and when you run a Docker image, you get containers. Docker containers. Typically this is the workflow of Docker. So a DevOps engineer or a developer write a Docker file, builds it, and get an image created, and when he run the image, he get containers. We can create multiple containers from same image. We need to have different names for that. What I mean to say, we can create multiple identical containers from the same image. What we need to make sure is the name of all the containers are different. Now, why do we need containers? Okay, so after this the question comes here is why do we need containers? Why do we need containers, and what we are going to run, and what we are going to run inside the containers. So ideally, whenever we create a Docker container, we have some application which is going to run inside the Docker container, and mostly Docker containers are feasible to run lightweight applications. And when it comes to lightweight application, we call it microservices. So ideally, microservices will be running inside Docker container, because containers are lightweight and they supposed to run lightweight applications. So microservices are smaller application. You can understand like this. So microservices are nothing. These are smaller applications. Okay, these are a smaller application, and these smaller applications will be running inside this Docker container. So we are not going in detail with microservices and Docker container. I'm just making the ground to help you understand why do we need containers, why do we need Kubernetes. So before understanding why and when we should use Kubernetes, we need to understand Docker. And when you create a Docker container, what you are going to run inside the Docker container? So we are going to run microservices, or you can say smaller application created in any programming language can run inside Docker container, irrespective you provide the respective environment for that. Now the question comes here is if I have one Docker container running X application, if I have one Docker container running one application, similarly if I have 10 containers, if I have 10 Docker containers running 10 microservices, what happens here is if the number of containers are less, we can manually manage it. What I mean to say, so if I have 10 microservices, we need 10 containers, and 10 containers can be managed manually. Imagine a situation, what if we have 50 microservices, 50 microservices need 50 containers, and it will be practically impossible to manage manually. So we cannot manage, we cannot able to manually manage multiple containers. There Kubernetes comes into picture. Now what is Kubernetes? We need to understand what is Kubernetes, guys. So Kubernetes is a platform. Kubernetes is a platform, or we can call it tool. Kubernetes is a platform or a tool which manages the entire container lifecycle. Okay, so let's go and take a look to the definition as well. So what is basically Kubernetes? Okay, so here we have the definition. Kubernetes is an open source orchestration tool or platform which is used to manage the entire life cycle of a Docker container. Kubernetes help us in deployment of containerized application, scaling of containerized application, and management of containerized application. Okay, so what this Kubernetes is? Kubernetes is a platform or tool which manages the entire container lifecycle. Kubernetes help us to deploy containerized application. It helps us to deploy containerized application. So if you are not able to understand what this mean is containerized application, in simple word, any application which is going to run inside a container. So any application which is going to run inside a container, that particular application will be called as containerized application. So with the help of Kubernetes, and or Kubernetes takes the responsibility of deploying containerized application, scaling of containerized application, and management of containerized application. Okay, now let's know more about Kubernetes. So Kubernetes is something called as K8s, and how this word is derived. So basically this word has been derived from the Kubernetes words. So basically K is coming from here, S is coming from here, and in between we have 8 characters. That is why K8s is coming. So Kubernetes is officially developed. Kubernetes is officially developed by Google a decade back, and now it is maintained by CNCF. CNCF is called as Cloud Native Cloud Foundation, and Google and the Linux Foundation created this CNCF platform. And earlier Docker and Kubernetes used to be best friend, but now Kubernetes has removed the support of Docker, and in place of Docker, Kubernetes uses containerd as a runtime. Kubernetes can be called as K8s and Hellsman. If we talk about current condition, okay, if we talk about the current conditions, so the latest version of Kubernetes that we have right now when I'm recording this is version v.12. So the latest version of Kubernetes is v1.32 is the latest version of Kubernetes as of now we are discussing. So latest version of Kubernetes is version 1.32, guys. Okay, and since Kubernetes is open source, so we can have the code available of the Kubernetes, the open source. Since the Kubernetes is an open source tool, we have the entire source code available on GitHub, where we can go. So you can go to github.com Kubernetes, and you can have the entire source code. Here you can see the latest version of Kubernetes released 2 days back is 1.32, and the entire Kubernetes has been written in Go programming language, guys. So development of Kubernetes development of Kubernetes is done in Golang. Okay, so we use is basically Golang for, we call it Golang, and the entire Kubernetes has been developed in Golang. Now if we talk about some of the features, if you talk about some of the feature of Kubernetes, okay, so when you will learn more, you will able to understand what these features are. As of now, I am just helping you understand. So Kubernetes help us in efficient container management, efficient container management, efficient container management. So as I told you in beginning, so if you have one container, you can manage. If you have two containers, you can manage. But imagine a situation if you are running a system where you have 100 containers, you cannot practically manage 100 containers. Then we need a orchestration platform. We need some sort of platform or tool that help us to manage the container lifecycle. There Kubernetes comes into picture. So Kubernetes help us in container management. It helps us in it helps us in maintaining highly available it helps us in maintaining the high availability of service. So it helps us in maintaining high availability of service. Scaling is one of the most advanced, and scaling is one of the most important feature Kubernetes help us, and Kubernetes is kind of self-healing. Okay, self-healing. There are some other features as well, but as of now I am helping you guys with the help of these many features. Okay, now let's talk about Kubernetes architecture going forward. So what Kubernetes architecture and how Kubernetes architecture basically look like. What is Kubernetes cluster, or you say Kubernetes architecture, or let's talk about Kubernetes cluster. Okay, so I'm going to draw a diagram that will help you understand what a Kubernetes cluster look like. So a Kubernetes cluster basically consists of two major components. So I am talking about, what I'm saying here is कि a Kubernetes cluster consists of two major component. Okay, the first one is called as control plane. We called it control plane, and another is called as worker node. Okay, so let's draw this particular diagram so you can understand this is kind of a network. You understand this can be a VPC. It will have the CID range 10.0.0/16. Okay, so this is a network. My Kubernetes cluster will be network, and this Kubernetes cluster consists of control plane. So this is called as control plane, and then we can have multiple worker nodes. So we can have worker node 1, we can have worker node 2, we can have worker node 2. Okay, even we can have worker node 3. So let me talk about some of the possibilities. So a Kubernetes cluster, if we talk about the smallest cluster, okay, so if you talk about the smallest cluster, the smallest cluster will be of one control plane and one worker node. Okay, so if we're talking about the smallest Kubernetes cluster, the smallest Kubernetes cluster can be with one control plane and one worker node. Okay, and if you want a big cluster, what is the biggest cluster can be possible? So biggest cluster can be with one control plane and 5,000 worker nodes. So you can have 5,000 worker node with one control plane. Now sometimes we have a concept that is called highly available control plane, highly available cluster. okay, highly available cluster. So in that situation, we go with 3 control plane, and we can have multiple worker nodes, multiple worker nodes. So there is no limit that you will be creating 10 worker node or you go with 20 worker node. It totally depends upon how many microservices or how many containerized application you are going to run. There is a separate calculation we can talk about in a separate lecture. What is the correct size of Kubernetes, or how many worker node we can choose for the cluster. How do we basically decide how big will be my cluster? Okay, so there is a concept behind that we will talk about separately. So here, as I told you, so we have this Kubernetes cluster consists of 2 major components. The first major component is called control plane, and the another is called worker node. So we can have multiple worker nodes. So there is a possibility that we can have multiple worker node. Now control plane consists of a very important component that is called as Kube API server. That is called Kube API server. The another component that is called as Kube scheduler. Kube scheduler. Then we have another component that is called as etcd. It's a key value pair database. And then we have something called as controllers. So we have some controllers here. So there are 2 type of controller. One is called as Kube controller. These are inbuilt controllers, and in Kubernetes we can have custom controllers as well. So this is Kube controller, and then we have cloud controller. Okay, cloud controller. Now when it comes to worker node, every worker node has certain components, certain components running, and these components run in every worker node. Okay, so the first component is called as container runtime, guys. Container runtime. Then we have something called as kube proxy. Then we have something called kube proxy. And then we have something called as kubelet. Kubelet. Okay, so ideally right now the diagram that I have drawn is a Kubernetes cluster. It's a Kubernetes cluster with one control plane, and 2 worker node, guys. 2 worker node. Okay, we can have multiple worker nodes. We can have 3, 4, 5, 6, 7, 8, 9, 10 up to 5,000, but it depends how many containerized application you are going to run. Accordingly you will be doing that. So this is what we have to cover from this particular lecture, and in the next lecture I will be covering in detail about Kubernetes architecture. We will be covering all the major components of this Kubernetes clusters. So we will discuss the entire Kubernetes architecture in detail in the next lecture, and I will be creating a entire Kubernetes playlist in a very simple language. And if you want the same thing to be explained in Hindi, let me know in the comments. Okay, and please do like and subscribe my channel. Okay, help me to grow as well. And for any DevOps related query, if you have any doubts or questions related with Linux, AWS, Azure, Terraform, Kubernetes, DevOps, MLOps, kindly get in touch with me. I will help you your doubt, and if you want to upskill help, please contact with me. Thank you. Subscribe the channel and share in your IT community, in your IT circle. Thank you.